Hello friends, today we are going to see some status updates, like how far I have progressed on creating this newsfeed app using the fast AI training. Also, we will look at the kaggle competition, for how far I have progressed. Also, we will look at personality, like some people who have good training materials towards data science. So let's jump into the. So here actually I started by an idea where I get the Malayalam text, put it into build a Chrome extension where it will display the news feeds based on categories. So what I have done here is it's a basic design where the Malayalam text from a RSS feed, it will be sent to a fast AI model, and from the fast AI model we will display the categories. So it was very difficult to set up all these things and do the recording. So what I have done is I have just created some screenshots, and I will just explain the entire process. So first what I have done is, from the notebook I created a Python script, and I dockerized the Python script into an API. So first step is to run the Docker and expose an API. Now our API is listening in 8080. So there is something in VS Code, there is an extension called HTTP client. So I have installed that extension, and when you send a request, we can test this whether we are getting the right inference from the model. So you can see the snapshot, because to run this and record it and show it live, my system will crash. I have tried it many times. So this is a screenshot which says that I'm getting the response from the Docker. Just you can follow along the timelines, like today at morning my time, I got this output. So my Docker is working fine, and there is a newsfeed app. You could see every 5 seconds it will read the RSS feed, and that news red news is a badge, which is a property of the extension. So I'm not going into the details of the code for the extension development. There are a lot of open source Git repos. I used one of them and tweaked it for my purpose. So when I click on that, actually the pop-ups were not coming in my recording, so I did a screenshot. When you click on it, you could see my the text, the Malayalam text from the RSS feed is being sent. Like, I have just chopped off some of the news which are not relevant for the context. So in the console you could see the text as we did in the REST client. It is the same way the text is sent to the API, and you could see there is a technology, business. Those are the labels that we get from the model. So this fair, like end to end, like just to close, like how from an idea how we can use the fast AI Hugging Face model in a live application. So I have some plans to create a chatbot, but my current focus is to look at the competition that we saw in the last video. In the last video I was talking about the Jeremy's. I just took a copy of it and started editing that, and I would like to share how I progressed and what are the changes I have done. So here you could see this is the latest where I'm using Hugging Face. So I started with a maze model, then actually from the notebook from last week, what I did is I explored different options. So I hope people look at it, and from there have been a lot of changes. Let me go to the there are a lot of versions. Let me click on edit. So let me go through all the versions. The reason why I'm doing this is so that if someone is starting, it will be helpful, or you can look at the resources. So I have created around 6 versions. So let's see like how, like from here, this is the base Jeremy's version. Like I treat like a grandmaster. I took it, and I'm just a beginner. I don't have any knowledge on the data science part. So whoever is just starting, they can start, or they can get this. These are just pointers. So from this, what I understand is there are some technical, like how you can load the data, how you can train a model, how you can tokenize it. So most part you need to fine tune the model. Jeremy has given some techniques, but some part I was very confused. The main reason is why he is concatenating the features, and how the classification. There are actually different label, like we have the problem statement is the patents anchor and target these features has to be classified as around 5 different categories. So we need to find out whether the target is identical to anchor, or whether it is close enough, or whether it is unrelated. So this is a classification problem, and for me, like I was struggling to find out how they approach this. So initially there are some data what he calls is EDA. It's a data analysis, like the exploratory data analysis. So mostly data scientists spend more time in EDA and inference tweaking, training inference notebooks. So what he says is, if you have effective data set, and so I was so they are very experienced, I'm just beginner, so I was trying to fill the gap. So what I did is I went into all the discussion forums in this competition, and I could make out like they have been doing lot of experiments in terms of feature engineering, in terms of cleaning up the data, in terms of model analysis. So there is a model called BERT. So I was trying to learn BERT. So there is a for example, there are a lot of blogs out there which explains the BERT. So even after understanding BERT, I don't know the ULM fit model, I don't know the ELMO fit, I don't know the vectorization. So what I did is, after going through all these documents, so there is the first thing is the data analysis. So for data analysis, first what they do is they look out for patterns. What is the distribute, and what are the unique values? Are these classification labels are evenly distributed? For example, in this case, do we have say from 100%, for example, 50% of the data is identical? Do we have enough distribution for all the classification labels? So these are some of the things I knew that they do. And there is one hot encoding, there is a tokenization. So when you do tokenization, what kind of model you need to select? So after all that, what I did is I started from scikit-learn, because I tried whatever Jeremy suggested. So one roadblocker I had is on the metrics. The metrics is where you have the prediction. When you should do a difference with the actuals, you will get a loss. You need to reduce the loss. So for this competition, we need to use the Pearson's correlation metrics. So there were some suggestions from Jeremy saying that you can try out different models which are trained on the patent, like BERT for patent similarity models. I tried these models from Hugging Face, and they were like huge models. One of the disadvantages is the Pearson metrics was giving negative. What that means is the predictions compared to the actuals, there were going like there were no correlation was very less. That means our model was the loss is so huge. So what I tried is I instead of just copy pasting things from other notebooks, I thought of why can't we do it organically? like do some critical thinking. So what I started is, I started from the base, like the way I learned is through scikit-learn package. So I started with scikit-learn. There is a document, there is a like how to handle with text data, scikit, sorry. So I started learning from there, scikit-learn text data classification. So this I started like I know things, but in order to solve a problem, like why they are using that was my intention. So from there what I did is I started reading the data in the way I want to. So I just use pandas. From pandas I created some categories. This is like I just followed as is this document. Then I understood like there are some concepts like best practices. You do a test, you create a train test, a data split. So I did a split. So when before the split I just took the column features which are relevant to the context. So here what it's a supervised learning. So what I understand is a supervised learning. So the reason why they append is this is labeled data set. So in the labeled data set, experts have already categorized this. So if you make this as a single text field and the score, you can easily train a classifier. That's what I understand, and I created a category. This is same what they have suggested in scikit-learn. And I just followed that document, and I'm not going one by one. And at the end the score was around 37. That means when it predicts it's around 75, probably close to 65 percentage loss. That means I need to improvise. So I took this model as a baseline from scikit-learn and I started building Hugging Face. So using the book that I have got, so I followed this book. So from this book I started the Hugging Face text classification. So I created a data set. So it's in progress. So as of now I have completed the tokenization. So tokenization, tokenization has evolved a lot. So from a text we converted numbers, and then we do one-hot encoding. There is character tokenization, there is word tokenization, there is subword tokenization, which is the best of character tokenization and word tokenization. So everything you can find it in the text. So I followed the textbook, and this notebook is, I have made it public. I will share it along with this video. So far I'm doing the feature exploration, feature engineering. So to take out the outliers, so that it doesn't overfit or underfit. So there is a Jeremy has created some notebooks for beginners following that. So as of now I understand tokenization, and also there are some graphs from which we can understand the distribution. So in this you could see that so I have label like close. So if you could see my class labels are something like this. Okay, where is it? So from okay, I have from like if you see here close, I have given the class labels are very close match, close synonyms. These are the classes 0, 1, 2, 3, 4. So 0 means very close match, 1 means close synonym. So if you see in the distribution, the distribution is like there are techniques to make this distribution even. Means the data set that we have is mostly of 2. 2 stands for say 0, 1, 2 close synonyms. so it will miss some unrelated data. So unrelated data classification will be poor when we do the classification, or the identical data is very less. So means very close anchor and target data is very less. So, and also the word length, I think I haven't used. The word length is around close to 5. So the word length matters when based on the models we select. So I'm trying to use the BERT, distill BERT, which is of performance wise it is more higher than BERT, and it's also the memory is compact. So far what I have done is I have understood tokenization. I have tokenized the whole data set. So I will update the how it comes up when training the classifier, what are the parameters I used. I will update in the, hope it helps. I don't know if someone is but it's just like whatever helps. So it's just a counter. And also lastly, I would like to introduce Craig. He doesn't need an introduction. He's been doing a lot of videos. So his videos I find it very helpful. So he has some a lot of playlists. So Craig's path to become a data scientist. This I followed to learn about matplotlib, and this is very like short, and you will get the basics and the essentials to start exploring data science topics. Hope it helps. Thank you.